Welcome to What Is, the show where we dive deep into the corners of the natural world to find things that probably shouldn't exist, yet somehow very much do. Today we're looking at an animal that looks like a gummy candy, hunts like a tactical SWAT team, and has been reusing the same biological blueprint since before the dinosaurs were even a twinkle in a reptile's eye. I'm talking about the Onychophora, or as you can call them, the velvet worm. Now before we get started, if you enjoy learning about the weird, the wild, and the why does this have so many legs, make sure to hit the subscribe button and ring the notification bell. You don't want to miss what we've got coming up next. Alright, let's talk about the velvet worm. Imagine, if you will, a creature that is part caterpillar, part slug, and part high pressure glue gun. It's soft, it's squishy, and it looks like it was knitted by a grandmother who had a very loose understanding of what a bug is supposed to look like. But don't let the velvet part of the name fool you. These aren't the plushies of the forest floor. They are highly efficient, ancient, and surprisingly social predators. First, let's address the name. Why velvet? If you were to touch one, which, honestly, they probably wouldn't appreciate, it wouldn't feel slimy like an earthworm or hard like a beetle. They are covered in millions of tiny, scale-like bumps called pupae. These pupae are waterproof and are what give the worm its matte, velvety sheen. They are basically the nature version of a high-end luxury car wrap. But under that soft exterior is a creature that hasn't changed its basic design in over 500 million years. To put that in perspective, 500 million years ago, North America was still hanging out near the South Pole, and life was mostly just things bumping into each other in the ocean. The velvet worm is what scientists call a living fossil, while everything else was busy evolving wings, or a backbone, or the ability to pay taxes. The velvet worm looked at itself in a Cambrian era puddle and said, yeah, this is fine, I'm good. They belong to their own phylum, Onychophora. This is a big deal in biology. Most of the animals you see fit into huge categories. You got chordates, that's us, dogs, birds, fish. You got arthropods, insects, spiders, crabs. Velvet worms, they're their own thing entirely. They sit right in the middle, like the missing link between soft-bodied worms and hard-shelled insects. They have these stubby, unjointed legs called lobopods. They don't have joints like your knees or an ant's legs. Instead, their legs are basically fleshy balloons filled with fluid. They move by changing the internal pressure of their body, which is called a hydrostatic skeleton. It's the same way a balloon animal would walk if it suddenly gained sentience and a hunger for crickets. And they have a lot of legs. Depending on the species, we're talking anywhere from 13 to 43 pairs. At the end of each little leg, tiny retractable claws. In fact, Onychophora literally means claw bearers. But let's get to the part that everyone actually wants to hear about, the weaponry. If you're a small insect, say a cricket or a woodlouse, the velvet worm is the monster in a horror movie. It stays in the shadows, it's nocturnal, it's slow, very, very slow. It creeps up on you with its sensitive antennae, feeling the vibration in the air. And then it brings out the cannons. Located on either side of its head are two specialized glands called oral papillae. Think of them as high-pressure nozzles. When the velvet worm is within range, it contracts its body and fires. Two streams of milky, translucent slime shoot out at a high velocity. The worm weaves its head back and forth as it fires, zigzagging the spray like a frantic firefighter, coating the prey in a sticky web of biological glue. This isn't just any glue. This stuff is a masterpiece of chemical engineering. When it's inside the worm, it's a liquid. But as soon as it hits the air and the target starts to struggle, the mechanical stress causes the proteins in the slime to harden into stiff, rubbery threads. The more the prey fights, the tighter the trap becomes. It's the ultimate stop hitting yourself move of the animal kingdom. The cricket is essentially shrink wrapped in seconds. And here's the kicker, the velvet worm is a master of recycling. Once the prey is immobilized, the worm crawls over, and because the slime is made of expensive proteins that take a lot of energy to produce, the worm eats the slime back up while it eats its dinner. It's like a hunter who shoots a net at the deer and then eats the net alongside the venison to save on equipment costs. Now, how does it eat something with a hard shell when its own body is as soft as a marshmallow? It uses those claw-bearer traits. It has a pair of sickle-shaped jaws hidden inside its mouth. It bites a tiny hole into the prey's exoskeleton and injects digestive enzymes. Essentially, it turns the inside of the insect into a protein shake. Then it just sucks the liquid out, leaving behind an empty, hollow shell. But wait, it gets weirder. We usually think of invertebrates as solitary, mindless drones. But some species of velvet worms, like those found in Australia, are surprisingly social. They live in groups, they hunt in packs, and they have a strict social hierarchy. There is a dominant female, the queen if you will. When the group finds a large kill, she is the first to eat. The other worms wait until it's their turn based on their rank in the hierarchy. If a lower ranked worm tries to cut the line, the queen will literally push them away. It's high school cafeteria drama, but with more slime cannons. Hunting in groups allows them to take down prey much larger than themselves. It's a level of cooperative behavior that's incredibly rare for something that doesn't have a centralized brain. Speaking of brains, the velvet worm's nervous system is also a bit of a throwback. They have 2 nerve cords running the length of their body, but they aren't fused like ours. This gives them a very decentralized way of processing the world. They aren't thinking about philosophy, they're thinking about moisture, shadows, and the next thing they can turn into a juice box. Moisture is the key to their entire existence. Because they have very thin skin and breathe through tiny permanent openings called trachea that they can't close, they are at constant risk of drying out. If a velvet worm stays in the sun for too long, it literally evaporates. This is why you'll only find them in dark, damp places, rotting logs, deep leaf litter, or caves. They are the ultimate basement dwellers of the forest. Now let's talk about the birds and the bees, well, worms. Velvet worm reproduction is where things go from weird to how is this real? Some species lay eggs, standard stuff, but others give birth to live young. And I don't mean eggs hatching inside the body. I mean some species have placenta-like connection where the mother provides nutrients to the developing embryos for months, or even over a year. When the babies are finally born, they are miniature versions of the adults. They come out fully formed and ready to start shooting slime and ignoring their parents. But the way the sperm gets to the eggs in some species is truly bizarre. In certain species, the male doesn't have a standard way of delivering his genetic material. Instead, he places a packet of sperm, a spermatophore, anywhere on the female's body, just drops it off like a package on the porch. The female's skin then dissolves under the packet, and the sperm cells migrate through her body cavity, swimming through her blood, which is more of a clear liquid called hemolymph, until it reaches her ovaries. It's an anatomical, all-terrain shortcut. So why should we care about this squishy, glue-spitting ancient worm? Because the velvet worm is a survivor. It has survived 5 mass extinction events. It saw the Permian extinction wipe out 90% of life on Earth and just kept on vibing in its rotting logs. It saw the asteroid hit the Yucatan Peninsula and thought, I hope it's raining, I'm feeling a bit dry. They are a window into a world that existed before bones, before flowers, and before trees. They represent a branch of life that found a perfect niche and stayed there. But even these ancient survivors are in trouble. Because they are so specialized for damp, stable environments, they are incredibly sensitive to habitat loss and climate change. If a forest is cleared, the microclimate changes, the humidity drops, and the velvet worms disappear. Many species are found only in tiny specific pockets of the world. Some species are known only from a single hillside or a specific cave system. This makes them incredibly vulnerable. When we lose a species of velvet worm, we're not just losing a bug, we're losing 500 million years of uninterrupted evolutionary history. So next time you're walking through a rainforest or flipping over a damp log, keep an eye out for a little piece of the Cambrian period. It might look like a discarded gummy worm, but it's actually one of the most sophisticated ancient hunters on the planet. Just maybe don't get too close. You don't want to find out how hard it is to get that slime out of your clothes. Believe me, it's a nightmare. That's all for today's look into the what is of the velvet worm. If you learned something new, or if you now have a localized fear of being turned into an insect protein shake, give this video a thumbs up. What should we cover next? Are there other living fossils that you're curious about? Or maybe a creature that's just as strange but doesn't have quite as many legs? Let us know in the comments below. We read every single one, mostly because we're looking for more excuses to research weird animals. Don't forget to subscribe to What Is for your daily dose of the world's most fascinating facts. Thanks for watching, and we'll see you in the next one. Stay curious.